Hey guys, welcome back. This is Trockers. We have a problem we need to tackle here from ZIMSEC 2006. The question reads, the equation 3z cubed minus 10z squared plus 20z minus 16 equal to 0 has 1 minus square root of 3I as one of its roots. Part 1, find the other roots. Part 2, sketch the roots in an Argand diagram. Then part B, express 3 square root of 3 minus 3I in the form RE to the I theta in Euler form. Hence, find the fourth root of 3 square root of 3 minus 3I, giving your answers correct to 2 decimal places. Right. So what we need to know here, guys, are the properties of polynomials. Remember, if you have a polynomial, say, if we have a polynomial ax cubed plus bx squared plus cx plus d equal to 0. Okay, I just restricted this to cubic since it's a cubic question. You need to know that for complex roots, one of the roots is the conjugate, so it will be 1 plus square root of 3i. Then another root will be sum of all three roots here will be equal to negative b over a. So when you just take the coefficient of the linear term, quadratic term divided by the coefficient of the cubic term here, you negate that. You take this the quotient for that. That is our root, so it will be minus b over a. Right. What else do we need to know? I think that's all for this particular root question. Then for item 2, we just need to sketch those roots in an Argand diagram. Then item 3, we want to express that in Euler form. So the first thing to do is to calculate our R here. Then you also calculate your argument, which is theta, right? And let's bear in mind that the argument lies within the interval from negative 180 to 180. Right, and the good thing about this question is they did not specify whether we are solving or whether we are working in degrees or in radians. So just choose what you want here, but let's not mix both radians and degrees. Okay, guys, let's go ahead and get started here. All right, so I'll go ahead and write this question down. Okay, so it's saying, first part of the question here, it's saying we are given that, so let me write this function here. Our equation is 3z cubed minus 10z plus 20z minus 16 equal to 0. So this is our polynomial, right? So since we are given that 1 minus square root of 3I is the root, the other root here on item A, right? So the other root is 1 plus square root of 3I, which is the conjugate. So the conjugate is the other root, right? So to find the third root, we are going to let the other root be x. So we know that sum of roots is equal to negative b over a. So in this case, it will be negative of negative 10 over 3. So if we sum up all three roots, we must get 10 over 3. So this implies that 1 plus square root of 3i plus 1 minus square root of 3i plus the unknown, which is x, should give us 10 over 3. So this and that cancel out, and we have 2 plus x equal to 10 over 3. So x equal to 10 over 3 minus 2, which is 4 over 3. So the other roots are 1 plus square root of 3i and 4 over 3i. Right. So now let's move on to part B of the question. So moving on to part B of the question. So on part B, we want to sketch those roots. So remember, guys, we have 1 minus square root of 3i, then we have 1 plus square root of 3i, then we also have 4 over 3. So when we go on an Argand diagram here, right, we've got a real part, imaginary of z, then we've got the real part of z here. Right, so the first one is 4 over 3. So 4 over 3 is likely to be here. Remember, we're just sketching, right? Because it's just the real number there. Then 1 plus square root of 3. So 1 is likely to be here. Root of 3 is somewhere there. Negative root of 3. Right. So these are the roots, right? You've got this part, you've got that part, and that part. So we have sketched the roots in an Argand diagram, right? So sometimes you can put a circle to show that these roots lie on the same circle since they have the same radius here, or just to leave it like that, right? So we have that, and we have that. So those are the roots, right? Which is our, so we've got our 1 here. So we've got 1 in root of 3i, 1 in negative root of 3i. Then we also have the 4 over 3. So those are the 3 roots that we have indicated in an Argand diagram. Right. So now we are moving on to part B of the question. Part B. All right. So part B of the question, we are given this complex number here, 3 square root of 3 minus 3i, and we want to express it in Euler form, in exponential form. We want to express it in the form r e to the I theta. So guys, it is very important that we know the quadrant in which this complex number lies. So since x is positive and y is what is negative here, so it is in third quadrant. So in the third quadrant, it will be just the negative of theta, where theta is equal to arctan of y over x. So now whatever we are going to calculate for argument, we just negate that. All right, so first we need the modulus, which is 3 over 3 squared plus 3 squared, which is square root of 3 okay, 3 by 9 plus 9, which is square root of 27 plus 9, which is root of 36, which is just 6. So our modulus here is 6, right? So we have our modulus and we are in our fourth quadrant. So our argument, arc z, is equal to negative of arctan of y over this. So make sure you don't put the negative inside, because I've already identified the quadrant in which this complex number lies. And it's going to be negative arctan of 1 over root of 3, which is negative pi over 6, or 30, negative 30 degrees. So that is the angle there, that is the argument. So therefore, z is equal to 6 e to the negative pi over 6i, right? I prefer to work in radians, so let me leave it there, right? So we have expressed that complex number in what? In Euler form. Now we are moving on to the hence part. Hence means use the above result. We want to find the fourth root for that particular complex number, and we have to express our answers to 2 decimal places. So guys, before we do this, there is something that I need to bring to your attention here, right? So remember, a complex number can be expressed in 3 different forms. We can express it in rectangular form, which is the a plus bi, or we can express it in polar form, which is, okay, so form number 1, we can express it in the form x plus iy, or form number 2, we can express it in the form r, then cos theta plus I sine theta, which is the polar form of a complex number, or the Euler or the exponential, which is r e to the I theta. So these are the 3 forms in which we can express our complex number. But Remember, if I want to talk more about this. So when a complex number is expressed in polar form, right? Like in this form here, R, where we have got cos theta plus I sine theta, right? I can convince you by saying that it is also the same as saying 2 pi n plus I sine theta plus 2 pi n. So adding or subtracting multiples of 360 degrees to our angle theta here, it's not going to change the position for that complex number, right? So it's either you can express it like this or like that. Then when we apply the de Moivre's theorem, say now we want to solve z to the n is equal to that, right? Which is our alpha here. So to get our z, remember r is just affected like directly with that exponent. But here it becomes cos theta plus, or maybe let me put a k here, right? So theta plus 2k pi. Then it will be now over n because I'm multiplying by 1 over n, right? Plus I sine theta plus 2k pi over n. So this formula here, guys, is very, 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 very important. You need to memorize this when you are solving when you're finding roots for complex numbers. You need to know this formula, right? But the good thing is when it's expressed in exponential form, the formula is just going to be r to the 1 over n, then e to the I. Instead of theta, you're now saying theta plus 2k pi over n, which is a good thing. Then in this case, you know that our n, right, will be equal to 0, our k, I mean, will be equal to 0, 1, 2, up to n minus 1, and n is the exponent, which is the degree for that polynomial. Okay, so now I'll go back to our question here, right? Let's go back to our question. What was it? It was 6e. All right, so I can move this here. Okay, no longer need this. Then I can move this up there as well. Okay, I need this. All right, so I want to take it from there. Okay. All right, let me move it there. All right, so we want to find the fourth root. So in this case, to find the fourth root, our z is equal to 6 to the 1 over 4 e to the negative, okay, here it's going to be e to the negative pi over 6 plus 2k pi over n is 4. Then I'm going to put my I, right? So this is that's the angle that we have here, right? Where k is equal to 0, 1, 2, up to 3, because there are only 4 roots, okay? So first, when k is 0, we are going to get fourth root of 6, then e to the, so if k is 0 here, it's gonna be, all right, it's gonna be, if I put 0, so it's gonna be minus pi over 24 I, right? But according to the question, we are supposed to leave the answer correct to 2 decimal places. So I'm going to evaluate that. Fourth root of 6. Okay. Fourth root of 6. Here it's 1.56, 1.57, I mean, to 2 decimal places. E to the, then this angle here, it becomes, all right, oh, let me change to radians here, mod. Okay, let me change that to radians, which is 4. All right, so when I change that to radians, I need to evaluate this one here so that it becomes, okay. So cos of that, if I say cos negative pi over cos negative pi over 24, right? Negative pi over 24, I'm getting 0.0.99144, right? If I multiply that by 4th root of 16, 4th root of 6, not 16. Okay. So here I'm getting 1.55, right? Then for sine, if I say sine negative pi over 24, okay, minus 0.130526i, right? If I multiply that by 4th root of 6, I'm getting minus 0.20i. So this is the first root, right? So this is the first root here. Now let me go ahead and find the second root. So to find the second root, okay, I need this down here. I need this down here. So let me remove this part. Okay. Okay. I can bring, okay, it's z equal to 4th root of 6 e to the negative pi over 6 plus 2k pi all over 4. All right, so we are done. When k is 0, this is what we got, minus pi over 24. Now, when k is 1, so it's going to be negative pi over 6 plus 2, negative pi over 6 plus 2k, plus 2 pi here. So it's going to be 23 pi, 6 times 2, 12, right? So it's going to be 11 pi over 24. So here it becomes 4th root of 6 e to the negative 11 pi over 24i. Let me double check. 6 times 2, that's 12. 12 minus 1, that's 11 over 24. All right, so now let's plug that in. Here it's going to be 1.57. It's not changing. So if I say cos, it's now 11 pi over 24. I'm getting 0.13. So it's 0.13015. It's okay. When I multiply that by 1.57, I'm getting this. So on this part is 0.20. Then when I say sine, right, sine of answer, okay, sine of answer, it's negative, it's 0.99 positive, so 0.99i. And here again, if I multiply by 1.57, I'm getting this. So, sorry, I was supposed to have written it here, plus 0.99i. So the answer here, plus 0.99i. So the answer becomes 1.55i. So this is the second root. So this is our first, that's our second. Now let's move on to finding the third root. So when finding the third root here, right, to find the third root, okay, so for the third root, that's when k is equal to 2. So it will be minus pi over 6 plus 4 pi all over 4. So this is 24 minus 1, 23 over 24. So here, our Z3, it will be 4th root of 6 e to the 23 pi over 24i. Then we do the evaluations again. This is not going to change. All right, so when I do cos, it's now 23 23. Okay, so for cosine of that, it's negative 0. So it's negative 0.99, right? Let's see for sine. Let's see for sine. 0.13, so plus 0.13 I. So as you can see, the 0.99 is this one. So we're going to take a negative 1.55, then here plus 0.20 I. So these are the two roots. And now we move on to finding the last roots, right? To find the last root. So to find the last root is when k is equal to what? Is when k is equal to 3. Let me see. So when I put k as 3, it's minus pi over 6 plus 6 pi all over 4. So 36 minus 1, it becomes 35 over 24. All right. So it will be 35 over 24. So here it will be 4th root of 6 e to the 35 pi over 24 I. Right. So let's do the same. The 1.57 is not going to change. So what is going to change here is the 35. Right. Then we start when it's cos. So when it's cos, it's going to be negative 0.99. Right. Then let's see when it's sine. Okay. Negative 0. So negative 0.13 I. So if you multiply again, remember for the 0.99 here, we get negative 1.55 here minus 0.20 I. So guys, we are done. We've extracted the 4 roots for this particular question. Right, so always let's remember this. Let me try to bring this down. So remember when you are given, when you want to find the roots, make sure you express it in this form, right? I think we got it from, which one? I tried to derive it here, not mistaken. I don't know where, I know that's fine. So always remember this formula here, Zn is equal to nth root of r, right? Then it's cos theta plus 2k pi over n plus I sine theta plus 2k pi over n. So this formula here, right? This formula here is very important, guys, where n is the exponent, r is the modulus, and theta is your what? Is your argument. Then k will take zeros from 0, 1, 2 up to n minus 1. Right. So with that being said, guys, I'm signing out. Stay tuned for more.